Hello everyone, my name is Haley Berkness and today I will be sharing a presentation on the carbon footprint in beef farming. I will be presenting information about two different methods of how beef cattle are raised for consumer consumption. The two methods of how to raise beef cattle are pasture-raised beef and feedlot corn-fed beef. I will be determining which method of production releases the least amount of greenhouse gas emissions. Moving on to our introduction and why it matters. So beef production plays a significant role in the global agriculture community and has considerable environmental impacts. Greenhouse gas emissions from beef production are a key contributor to climate change. And understanding the differences between grass-fed and grain-fed beef helps inform sustainable practices and consumer choices. A few overall key topics that we'll be talking about in this presentation are the carbon footprint and greenhouse gas emissions of beef cattle, animal welfare, resource use and land impact, sustainable practices to help minimize greenhouse gas emissions in beef production, as well as a conclusion slide. An overview of beef production methods. Grass-fed beef. Grass-fed beef cattle are raised on pasture for their entire lives, feeding on grass and natural forages. These cattle typically have a longer production period between 18 to 24 months and are generally have generally smaller carcass weights, averaging around 1,200 pounds at slaughter. Grain-fed beef, on the other hand, are finished in feedlots with high-energy corn and other grains for about 120 days. These cattle are faster when it comes to growing. They are sent to slaughter at 14 to 18 months. And these cattle also have a higher final weight, with carcasses averaging about 1,350 pounds. This is a diagram that shows the entire beef cattle life cycle. Throughout this life cycle, proper nutrition, healthcare, and management practices are essential to ensure the health and well-being of cattle and the production of high-quality beef. The finishing phase is the difference between pasture-raised beef and grain-fed raised beef. Moving on to greenhouse gas emissions. On the grass-fed side, cattle have longer lifespans and a high forage diet, which leads to increased gut fermentation and methane emission release. This is a natural digestive process in ruminant animals. Methane, CH4, is a potent greenhouse gas, trapping heat 28 times more effectively than carbon dioxide. Grain-fed cattle have shorter lifespans and a grain-based diet, which results in lower methane emissions. The shorter the finishing time and higher energy diets contribute to a smaller carbon footprint. Grain-fed beef has about an 18.5% to 67.5% lower carbon footprint than grass-fed beef. In regard to animal welfare, grass-fed animals typically have access to pasture throughout their lives, allowing them to exhibit natural behaviors and graze on diverse forages. This often results in lower stress levels and improved overall welfare. In contrast, grain-fed animals may be confined to feedlots and fed a high diet of grains, which can lead to health issues such as digestive problems and discomfort, potentially impacting their welfare negatively. Resource use and land impact. Grass-fed beef requires more land due to the longer grazing period and lower productivity. This may lead to deforestation if extensive grazing practices are used. Grass-fed cattle can utilize land which is unsuitable for crop production, potentially offsetting some of the environmental impacts. Grain-fed beef, however, are more efficient with the land. They have higher productivity in a shorter time frame. They can raise more cattle on less land, reducing deforestation risks. And Grain-fed beef also relies on cultivated feed crops, which require the use of water and fertilizers. A few sustainable practices which farmers can use in order to have better grazing techniques are techniques such as rotational grazing and crop covering, which can improve soil health and sequester carbon better. Regenerative practices can enhance biodiversity and reduce overall emissions. The grass-fed systems can contribute to carbon sequestration through healthy grasslands. Efficient management. Advanced breeding and improved management of cattle can increase production efficiency and reduce emissions. Proper feed management and energy use can further lower the carbon footprint. Both grass-fed and grain-fed systems can benefit from these practices. Rotational livestock grazing, as depicted in the image below, involves moving animals through a series of pastures on a scheduled basis, offering benefits such as improved pasture health, better forage utilization, and reduced parasite loads for the beef cattle. This practice promotes soil fertility, water conservation, and sequesters carbon while providing habitat for wildlife. In conclusion, the debate between grass-fed and grain-fed beef production involves complex considerations regarding environmental impact and animal welfare. Grass-fed beef, generally seen as more of a natural and animal-friendly, tends to produce higher greenhouse gas emissions due to the methane generated from high forage diets. It also requires more land and has longer production times, leading to lower productivity. In contrast, grain-fed beef is typically more efficient in terms of resource use and production speed, but it also involves a higher confinement rate and less natural feeding practices, contributing to the increased stress and health among cattle. Despite these drawbacks, grain-fed methods generally have a lower carbon footprint due to shorter finishing periods and higher energy diets. Thank you.